Wait, I'm supposed to share. Got it. Share. All right. Hello, welcome. This is the Kubernetes SIG storage community meeting about per volume CSI capabilities. As we agreed last week, this is now a weekly meeting. And we're going to keep doing weekly meetings, I guess, until we get things sorted out to the point where we can agree. So I wanted to pick up the discussion where we left off last week. I wrote notes for anyone who wasn't able to attend. And if you were able to attend, you can let me know if my notes made any sense or if I missed anything important. Real quick, they're just down here. My memory, I wrote these from memory, so it's possible I forgot something, but my memory was there were 3 overall solutions that were proposed. And I tried to capture each one of them and their pros and cons in my notes down here. And so I just wanted to go over a summary of these options and then I guess get back into the arguing about which one we should actually do, because I think we need to agree on an approach before we can get into the next level of detail. So any questions before I launch into that? All right, everyone seems happy. So the 3 high-level solutions were, first of all, we could require that we solve this by splitting CSI drivers into multiple drivers with 1 driver per protocol, so that the existing CSI interface would solve all these problems by itself, right? That if we do that, no CSI level changes are needed, but we just have to figure out how to overcome the momentum that we already have in the wrong direction. And I'm kind of opposed to this one on the grounds that so much upfront work would have to be done before we could even get to the point of fixing the CSI drivers, that we wouldn't see the solution to these problems for a long time. And I'm not even convinced we would ever see it, but it's still on the table because it has a certain elegance to it in that we don't have to change the CSI spec if we go down that path. The second option was, wait a minute, let me scroll down here to remind myself. Oh yeah, we could treat each individual problem as a new feature in the CSI spec. So we could go one by one and say, okay, for the FS type or FS group policy problems, let's go add a new CSI spec feature to solve that problem. For the SE Linux labeling issues, like let's add a feature to the CSI spec for that. For the maximum volumes per node issue, like let's add a new feature to the CSI spec for that. We could just sort of take these one at a time and update the CSI spec and address them sort of on a case-by-case basis. And from my notes here, the benefit of doing it this way is we can solve all of our problems that way. I mean, there's nothing that can't be fixed by just updating the CSI spec, I don't think. Some of them will be more heavyweight changes than others, but one could imagine a redesign of the volume limits per node feature to return more information that would enable a CO to actually get to the right answer. One could imagine specifically calling out, FS group, the ability to, set FS group information on a per driver basis in a way that kubelet could always do the right thing. Same thing with SE Linux. So that's sort of the second high level approach. And I don't know how many people were in favor of that one, but I find it more appealing than the first one. The third approach was the one that I was proposing. Oh, someone pasted something in here. Okay, we can look at that in a minute. The third approach was to basically take the hack that Kubernetes invented a while ago, which is this CSI driver CRD, which allows driver authors to basically tell Kubernetes to do certain things when their driver is in use in a way that's outside the CSI spec, and therefore is really, easy to implement changes to basically extend that hack to be a little more flexible, either by having multiple instances of that object and selecting which one to use on a per volume basis, or by extending the object itself so that based on some key that comes back from the driver, you would be able to look up certain behaviors instead of have one constant behavior for the whole driver. The big downside to that one is it only solves some of the problems that were raised last week. In particular, it would help solve my problem of the FS group policy concern. It might help with the SE Linux labeling, but like it definitely would not help with things like volume node limits. So we would have to do something else for problems that this doesn't solve. And those were the three approaches, and they all have pros and cons. And who wants to sort of argue for one of them or throw out a fourth option that we didn't capture last week? Anyone?
I just a comment on option 2. I guess even though it seems kind of heavyweight to like change the CSI spec for each of these things, in practice, especially for the bigger vendors, having changes to their CSI driver on their own is actually a fair amount of process as well. Like, as mentioned, there's like, you have to address legacy things. You have to figure out how to make sure upgrades work successfully and such. And so in some way, like doing this work through the CSI spec, having things more regular across the community has a lot of benefits. And I think the overhead of the process of changing the spec may not be quite as high as it initially seems, considering that there's a lot of overhead anyway. Anytime someone is changing a driver that is being shipped with their Kubernetes deployment.
Yeah. So I'll echo that. I mean, it sounds like what you're basically agreeing that option number 1 is really expensive. And in comparison, option 2 doesn't look so bad. So yeah,
exactly.
Just to sort of get everyone on the same page, my concern with option number 1 is we would first have to address the problem of why driver vendors lean towards this unified driver for multiple types of volumes in the first place, right? We would have to address the issues with the need for multiple node plugins, the need for multiple sidecars, the need for multiple copies of the sidecars. We would have to solve all those problems to get to the point where like a driver vendor would even want to do the thing that is suggested by option 1. Then we would have to figure out how to help people migrate from their legacy situation to the new, in theory, better design of having separate drivers, and that's a whole separate migration problem. And then only after you solve those two very hard problems can you actually expect driver vendors to start splitting apart their drivers, and some of them might not do it anyways. Like I don't know if I could convince NetApp, for example, to do that hard work, but I can definitely say that I couldn't convince them to do it until we solved those other problems. So like it would be a long path just to get to the point where we can start to solve the problem, and even then success isn't guaranteed. So I'm very nervous about saying like that's what we actually want to do, because there's a lot of work and no payoff for like maybe a year, maybe longer. With the second one, I will say that while it's not a ton of work to amend the CSI spec, we do have an alpha GA cycle now for new stuff that goes into CSI, and there is a time delay. Whereas let's say best case we propose a CSI spec change tomorrow that addresses all of our problems, and we get it merged tomorrow. Like that would go into the CSI 1.7 version, which would be released sometime later in the Kubernetes 125 cycle. Kubernetes 125 would probably pick up the new CSI spec before the release, but everything would be alpha. And then any features on the Kubernetes side that would implement the new CSI stuff would probably go into 126, and they themselves would be alpha in 126. And then I guess what I'm saying is there's a time delay just because of the alpha, beta, GA cycle. Like it's not a ton of work to do the second one, but there still is a time delay, right? Because no matter how small the CSI change is, it has to go through the cycle and get alpha, beta, GA on both sides before it becomes widely available on the Kubernetes side. So it would still be potentially, I don't know, 9 months to a year before like it would be beta on the Kubernetes side and enabled by default in the best case. It would be much less work to get there, but the amount of time that would elapse would be still pretty high. So that's one reason that I gravitate towards option number 3, is because it's the kind of thing you can do quickly. But I agree that there's doing it properly in the CSI spec has its appeal. It's just we have to accept that it would take a while to get it done.
I mean, are there potential options for accelerating that for features that are purely additive and, you know, and so don't have the same upgrade breaking compatibility problems that other spec changes have? And I don't need to answer that question here, but just kind of putting that out there that like,
no, I mean,
yeah,
we should sketch it out and say, okay, like best case, let's imagine we did get it merged to the CSI spec tomorrow and release it, and then merge and then do a release of the CSI spec and pull it into Kubernetes and start trying to consume the feature. We could figure out exactly how long it would take. You're right, it might not need to be feature gated. It might just be something that I don't know. Sheng, you have experience with alpha CSI features. What is the rule for consuming an alpha feature on the Kubernetes side?
Oh, in my case, because there is well, it depends on whether it's an in-tree code or if it's just external repo code, right?
So this would be like a new capability that kubelet would have to interact with.
Oh, then right? You need to have a feature gate, right? Like the voting health that we added to kubelet, we have a feature gate, so that will need to go through alpha, beta, and GA, and then so now we are moving to beta. Like at this time, we'd like to move the CSI spec feature to GA from
right.
alpha to GA.
But can an alpha? Let's say we add the feature gate to Kubernetes, and it's alpha initially. Can it consume a CSI feature that is itself alpha? So they're both alpha.
I think it's just not nice. I think. That's why we actually, I think we kind of rushed to move there's a CSI capacity tracking related feature that we moved that to GA, right?
But while
it's just
while a CSI feature is alpha, can it be consumed at all? I mean, I would hope yes.
Yeah, functionality, yes, you can. But I'm just.
If a Kubernetes, if a CSI feature is alpha, then yes, it can be used like as an alpha feature in Kubernetes for sure. Like we are doing that for volume mount group, which is alpha in CSI spec, and it is beta in Kubernetes. It was introduced as an alpha, but it's a beta now.
Wait, so Kubernetes considers it beta, but it's still alpha at the CSI layer?
There's no beta in CSI.
I know, but I would have assumed you would go alpha both and then GA on the CSI spec and then beta on the Kubernetes side.
We are proposing CSI spec GA now, and when we are at the same time we are trying to like propose the GA Kubernetes. So same time, similar thing I think happened with the what was it? The capacity tracking.
Yeah, I think we forgot about it, and then because we were rushing to move that to GA, then we remembered, okay, we should also do this on CSS spec. So
okay. So what I'm hearing is that the best case is you could actually do alpha at the same time for Kubernetes and CSI. We could introduce a feature. We could write the KEP, do a feature gate, get the feature into the CSI spec, release an alpha version, merge that into Kubernetes, release a Kubernetes alpha feature, all in one release. And then ship that, and then in one more release, assuming there's no problems, you could in principle go to beta. So the best case is 2 releases from the time that you get your KEP approved, and we're kind of missing the 125 feature freeze because that's like what, next week or something.
Yeah.
So like realistically, the best case is alpha in 126 if we go down to the option number 2. But then we could have beta in 127 and it could be turned on by default. Best case.
So actually, could you clarify a bit exactly how like the CSI spec goes through? Just because, to take an example, like you can add new fields to the Kubernetes, even a v1 API, and like that's separate from a feature gate being enabled. Like, is like taking the same view with the CSI. If we see the CSI spec as an API, if we're adding a field or something that has, nice, super clear upgrade semantics and stuff, then the actual feature gate would be like on the CSI driver side as to if it consumes that new field. But in terms of the field being available in the API, that can be done immediately and doesn't need to go through an alpha.
I think we're getting more strict now. Like there's this, what is the example? Node expand secret thing. It's a field that we are adding into PVC. It's a PVC spec, I think. So we actually,
I think he's asking about the gRPC, and I can answer real quick. The agreement that we reached on the CSI community was we were going to have an alpha process. There's no beta. It just goes from alpha to GA. But the idea was, for brand new features, we would initially tag them as alpha, and because of the semantics of gRPC, that means that the field slot that's consumed at the gRPC layer is dedicated to that feature forever. But we can deprecate alpha stuff and remove it, and if we decide it doesn't work out. So the idea is, if we introduce something new with the CSI spec, we would tag it alpha. It would consume a slot in the gRPC message, and then if we later decided to back that out, that slot would just be lost. But we would reserve the right to do so as long as it was alpha. And then, assuming things went well, we would promote it to GA, and then it would just be permanently in that slot. So it was just a way to give ourselves a way to try something out without promising not to remove it. And then when you promote it to GA, that's the promise not to remove. And so far, that's been a workable scheme for the gRPC. But yeah, it would mean that like Kubernetes couldn't start consuming it for like a GA level until the CSI spec had made that update.
So then, like, what exactly do you mean by Kubernetes consuming it at a GA level? And like the thing I'm speaking of, just like super specifically, I'm thinking of GKE, where you basically can't create anything close to a prod cluster that has a alpha feature gate enabled, but anything that is beta can be. But and I guess the thing here is that it isn't clear to me that there'd be a Kubernetes feature gate involved, and if there's not a feature gate involved, then like again, thinking selfishly of a GKE case, it would be a lot easier for us to launch and test something like at our own cadence.
Let me try to hand wave my way through like an actual version of this. Like so my specific, the thing I'm interested in is FS group policy in particular, because some volumes that the NetApp driver creates, they need kubelet to do the recursive chown to get the FS group set correctly, and other ones you can't. And so what would be ideal from my perspective is to have some Boolean flag that's returned at volume creation time that Kubernetes would remember or be able to access at runtime, so that when kubelet gets to the point in its code where it's going to decide, do I do the recursive chown or not, instead of just relying on the current mechanism, which is to look at the CSI driver object and some other features of the PVC, if you had a feature gate flipped on, it would say, okay, instead of the old behavior, I'm going to go ask the CSI driver, what should I do? And it would use a new alpha CSI feature that would just tell you, oh, This is one where you do the recursive chown, and this is one where you don't do the recursive chown, and it would just know. And then, and again, by default, customers would not get that behavior, right? The feature gate would default to off, so it would just be the old way, but people could flip it on if they wanted and get the better behavior. And then if everyone was happy with that, you would move the kubelet feature gate to beta, so it would default to on, but then it would only work with drivers that implemented the feature. So there would have to be some capability check, you know, for older drivers that didn't implement that feature, they would have to know, okay, do the default thing. But for new ones that do the new thing. And then eventually it becomes a GA thing at the CSI layer. And then you can just declare the feature GA on the Kubernetes side, and then you stop having a feature gate, and then you're done.
Yeah. Okay. So in the case you're thinking of, because you're making changes to the kubelet, there's going to be a Kubernetes feature gate that is in alpha for a release anyway. So like you basically do have that like two plus release cycle, depending on whether you make the feature freeze or not, basically, right?
Yeah.
Yeah. Okay.
And that approach, I think, so we could do that for the FS group policy. I think we could do something similar for the SC Linux labeling, because again, it's just the driver telling kubelet whether this particular volume has the behavior that wants SC Linux labels or not. I think. Right. Someone correct me if I'm wrong. And then for the per node limits, you need a different feature. But again, I think it's I don't know what consumes it. If it's kubelet or if it's the scheduler, who consumes the node limits? And where would that feature go?
It's sent by the drivers to the kubelet, which sends it to the kubelet, adds it to CSI node object, which is consumed by the scheduler to decide, okay, whether slots are available on the node to mount a new volume. So technically you could also
but the communication between kubelet and the scheduler is itself not flexible enough to do the right thing, right? You'd have to enhance that first before you could
yeah, exactly. Because I guess the thing that I'm wondering is, like, does changing the CSI spec add an additional release latency over what you have to do anyway for the kubelet feature gate in this case?
I don't think so. I mean, if you get your KEP approved and you get the CSI spec change approved all within about a month of each other, then you can get the CSI spec released in time for the code freeze and get everything in alpha all in one release. It does require a little bit more coordination, but there's no reason you couldn't achieve that.
So it seems as if Michelle had something to say, but her mic is broken. And I suspect she might actually know the answer too, which would be
great. By the way, for the volume limit thing, it's going to be a problem because the CSI node, the same object that carries information for both the block volume or the shared volume type. So even if the driver could tell the kubelet that this volume does not support limits, that information does not flow back to the
I was going to say that you'd have to have enhancements at multiple levels to make everything smarter, to understand the concept of, like, I can only have 26 SAN volumes, but I can have 1,000 NFS volumes or whatever the actual limits are, right?
Yeah.
So it's like the capability reporting needs to have something like a per volume type or something. It's because right now it's a controller level, right? When you report it, controller plugin level. So it's like we need to add something.
Well, I mean, it's keyed by the CSI driver name. When you get back to the scheduler, the scheduler doesn't know what if it's an NFS volume or iSCSI volume. It just knows that it's that particular CSI driver.
Well, but no, I'm saying it's almost like we need to return different things. So that's not sure how to do that. So when the CSI driver return, the capability is need to return either true or true for block, but false for
it would need to return a map. And then there would need to be a way for Kubernetes to know that within one particular CSI driver, there were like multiple subtypes. And Kubernetes would have to become aware of the subtypes, and that would get pretty messy. I totally admit that.
Same problem applies to, I think, the capacity tracking information also, by the way, just not node limit. It's maybe not as widely used because not many drivers report how much capacities available is mainly topo LVM and local volumes for now, but like if
capacity tracking is even more complicated, because if I recall, the way it works is you call like get free space and then you pass in like a volume capabilities, right? And it gives you how much total space matches that requested volume capability. So if you send in nothing, you get back all of the free space. But if you send in a volume capability that like in theory maps to iSCSI, the driver should in theory return how much iSCSI space is available. But like, that's not exactly how it works, right? The volume capabilities don't map cleanly onto protocols or volume types. So in reality, what can happen is you can get answers that double count space or that partially count space.
You return what's the maximum size of the volume you can create.
That too, yeah. But I guess I'm just saying volume capabilities, which are the input to that particular RPC, don't map cleanly to protocols on the other side, which is where you would, at least where the question of how many volumes per node you can attach at one time is really important, right? There's a big difference between attaching an NFS volume and an iSCSI volume in terms of what the node needs to do. But in terms of how much free space you have, at least on a NetApp device, we don't care if it's NFS or iSCSI. It's coming out of exactly the same storage. So you'll get the same answer no matter what you ask. But a different driver might be totally different. So
you're saying for you, actually, that's not a problem for you. It's actually, you return the same. You can return the same.
I'm just saying for
this particular problem, at least. This particular,
yeah.
Okay, yeah, but for some driver definitely it could be different, right? For some driver, it's yeah, definitely. So it's hard.
Should we also like at least consider option 1, like how we can do like while we're doing this? I mean, if I don't know this, yeah.
I mean, we have to keep considering it, but again, my complaint is, if we go down that path, there's going to be a lot of upfront work that might lead us to no ultimate fixing of the problem.
The problem is that, like Michelle is saying, see, option 2 and option 3 doesn't solve all the problems. Like we cannot solve volume limits, like problem, just because even if we our driver reports the capabilities, what it supports on per volume basis at the CSI spec level, it still cannot differentiate, disambiguate between like volume limits and capacity tracking, because there's again for the entire volume, and we don't have primitives in Kubernetes to report that stuff for like for sub volume type that you're talking about. It gets
I agree. It's harder. I'm not willing to grant that it's impossible. It's certainly not as simple.
For option 1, like even let's say we can solve the problem with option 1, like how many driver we expect to have to completely solve. So how we like define, if we say 2 drivers can solve all the problems, that might be okay. But if we need to have 3 or even more drivers to be able to solve all the problems, that would be a lot of work.
Definitely more than, I think it's more than that. Definitely more than 3, I think.
It's it's like depends on how many protocol one particular driver is bundling. It's like for example, vSphere bundles 2 protocols. Azure file bundles like 3 or 4 protocols in same driver name. It's
NetApp as well, and then I think there are other
NetApp Trident has 2 today, and I think we just added a 3rd in the recent release.
Yeah, so that's the thing, right? So Ben, why do they make decision to add yet another one? It's given that they should already know there are problems with even 2. Why don't you write a third? Let's say start from, since you're adding a new capability or a new protocol, why don't you just write a new driver for the 3rd one? Why do you want to still add to the existing driver?
Well, I mean,
it's complicated.
Right. So the answer is, first of all, like it's just too expensive from a runtime perspective to have like 3 copies of your driver running, right? It takes 3 times the memory, it's 3 times the pods. it's a big mess. It's not, I mean, it's just not appealing from a, deployer perspective to have triple of everything to install the driver. And so as long as
like I just do a big, like this is something we're actually starting to see in GKE as well, that like the node daemon sets are like getting increasingly trivial, and if it's a fairly niche driver that isn't used a lot, because there's not really any nice way to sort of deploy the node driver on demand.
Right. Yes. I was going to say that,
like a scalable solution to add more, because especially in like a managed setting, the thing that you want to do is have these drivers available without the customer having to explicitly deploy them. And when they do get deployed, they're deployed across the whole cluster. And so if there's a customer in a multi-tenant situation where only a small fraction of the nodes are using some particular storage feature, you still have to pay the tax across all nodes, and that tax is paid by the customer too, right? It's their compute.
I was going to say, if Kubelet was smart enough to understand CSI drivers and spin them up on demand instead of just having them always sitting there waiting for work to do, that would dramatically reduce this problem, right? Because then you could just have 10 CSI drivers installed, none of them would be running until one was needed, and then Kubelet could just do whatever was necessary to spin one up to go attach a volume. It would solve all kinds of problems if Kubelet was smart enough to do that. But we don't. So maybe that's something we should do. Maybe we should work on allowing CSI drivers to not run and have Kubelet have a way to spin them up on demand, and then spin them down when they're not needed anymore, and then save you memory when you don't have any attached volumes. I like that idea.
But it will be hard. Kubelet how know ahead of time which one need to turn it down, because it's next moment I have.
Yeah, absolutely. And until nodes have swap, basically, I think the personal opinion I've come around to is until nodes have swap, it just isn't going, that's going to be super hard to do, because if there's customers who have their nodes packed super efficiently, the extra memory consumption from a CSI driver can make all sorts of cascading problems if there's no swap.
Oh, I see what you're saying. You're saying that the act of starting up a new CSI driver to attach a volume could throw off your resource balance.
It has, yes. This is something we've seen, yeah.
Oh, I never would have thought of that. So that's interesting.
So if we redesign CSI spec with the idea in mind that a driver might support different type of volumes, how we might consider to redesign the spec?
Well, yeah, I mean, it would be as simple as just returning a quote subtype for every volume created, and then Kubernetes would have to remember the subtype, and then every time Kubernetes was treating a volume, it would need to know both the volume's driver type, if it was CSI, and a subtype, and that would have to follow that volume around everywhere it goes. So there would be Kubernetes work to consume a subtype feature.
So then volume type, if we think more detail, how we define those volume type. So right now we have some volume, not like mode, right? RWX or WO or RX.
Those are the access modes.
Yeah, access mode. But if we define volume type, how it's, do we have a way to define some kind of a context, right? Volume based on this volume type or context, and you have different capabilities. Is that possible to have?
Well, it would. If we go down that path, I would say that the subtype would have to be some opaque string, just like the CSI driver name is, right? The CSI driver name is an opaque string, and Kubernetes treats it as such. And so if there was a subtype, it would just be another opaque string, and you'd have to have both opaque strings to disambiguate any particular CSI capability. So like,
what do you mean the opaque? The driver name is there, or it's in the storage class, right? What do you mean?
yeah, but I mean like, so I think ours is called what Trident, your CSI.trident.netapp.io or whatever.
Right.
So like Kubernetes doesn't care about the format of that string as long as it's unique. It just stores it and then it uses it to look up.
Class field though, right? It's first class field.
Yeah.
So yeah, that's why I paste the volume spec in the end. I would just want to see ideas like if we do want to improve the CSS spec, what's the direction we want to go.
Okay, so yeah, so Jing, you pasted
yeah,
this in.
Yeah,
okay.
I just copy the spec. Like I want to hear some idea.
Oh, right. So this is the Kubernetes CR that we're currently using to do things outside the CSI spec. That's what you pasted here.
This is the struct for CSI driver, right? It's defined
right.
in Kubernetes.
Yeah.
So
like,
that's
yeah.
the difficulty, like because the driver can handle many different type of volume, and each field might be different based on your volume type. Is that
so proposal number 3, yes, is to like actually just have multiple instances of this object, one per subtype. That's my proposal number 3, or to have individual fields converted into like maps. So instead of being a singleton, you'd have FS group policy would be a map of subtype to FS group policy.
Can we? What if we have like get plugin info, both control plane and the node side returns more than one, like it returns an array rather than one driver in CSI spec, so that it.
Well, hold on. The whole thing about the CSI driver object is that this is completely outside CSI.
No,
right?
yeah,
this is
sure,
all
sure.
Kubernetes proprietary.
Yeah. No, I was saying about like if we have to design CSI spec to support multiple volume types within one, can we like consider that the get plugin info call that CSI the kubelet makes, it returns basically an array rather than one value, so that the driver tells, okay, I support these different volume types. And then Kubernetes can go ahead and pick and choose whatever it wants. It still leaves us with a problem of existing PV type that are deployed, but it probably, yeah, it will help with newer type, like newer driver.
Yeah. So for backwards compatibility, you would always have to have a default driver wide option for if you don't know what the subtype is, right?
Yeah.
So that backwards compatibility is very important. But yeah, like going forward, if you do know the subtype and both sides agree to know it and track it, then yeah, you could ask better questions and get better answers and do the right thing.
So it means it will create multiple CSI driver objects to represent.
That was my third proposal. Was yeah, just instead of trying to do something complicated, just say, look, we're going to have multiple of these things and have a way there'll be one CSI spec change to return some key that would be enough for Kubernetes to figure out which one to look up.
So this way it can solve like most of the problem mentioned here, right? Including volume limits, etc.
No, the problem is this doesn't help with the volume limits because this object says nothing about volume limits. This is just the Kubernetes proprietary stuff that we decided not to put into the CSI spec. We did put volume limits directly into the CSI spec as a proper feature. And so it would need to be redesigned to address that particular use case. Now, we could say that use case isn't important enough to bother with, and we're going to ignore it for now and just focus on the other ones. But that's a decision we have to take. I personally would like to solve that one as well, if we can.
So is that possible to put information here with that limit? No.
Then you probably still need it in both places, right? Because that one is returning some number, some limit. And then somehow it has to match some value here.
Is it the node plugin or the controller plugin that returns the value?
It should be node. So
node plugin.
Yeah.
Okay, so in principle, each node could have a different limit, right?
Right. Yeah.
That's one of the weird features of the way this works. So we can't put it in this object because this object is global. As long as each node gets to tell you its own limit, then you would have to ask each node what its limit is for each type to get the right answer every time.
Yeah,
we would just...
that was necessary because like on EBA, like AWS or GK, you have larger instances support larger limits. So
yeah.
Right. So is that possible to put a map here, like for each node, or
no? Because nodes are dynamic, right? Nodes are created and destroyed dynamically all the time.
And you can update it.
But like something would need to do that updating, and it would be doing it by talking to the CSI RPC. So you may as well just do it through the CSI RPC. Because you need code running on the node to go ask the question of how many volumes can you support.
Right.
And there's also the other one, which is the list volumes. That's the that's the controller side. That's also depending on the.
Okay.
Hold on, what is this use case, Xing? I haven't heard of this.
Well, so I think Sandeep added two, right? Sandeep added two. One is the volume limits, right? And then the other one is list volumes that returns the published node IDs.
The
two. He listed
right.
two issues.
Yes. So some you can return the published nodes for some volume types, but not others. And I guess
for RWX we cannot. For RWO we can. Yeah, that's the thing. So basically, for that particular capability.
I had forgotten about that one, but my response when he raised that, and I don't think we have Sandeep here today, but last week when he brought that up, I pointed out that you can solve that entirely on the CSI driver side by just by storing states somewhere to keep track of which nodes a particular volume is published to, and that's actually what we do with our drivers.
Okay.
Even if the storage system itself can't tell you, the CSI driver can remember.
Kind of like you have a cache in your driver, save that.
It's not a cache. It's actually a persistent data store where we keep track of which volumes are published to which nodes, and it's always accurate, and it's reconciled with the external attacher and the whole. I mean that's the whole purpose of the list published nodes, or the published nodes feature of list volumes, is so that external attacher can ask you what should this be published to,
it'll be some central map, but accessible to all the nodes and everywhere.
No, it's just access to it's accessible to the controller. The controller needs to know.
But the controllers can move. What happens then?
Yeah. The controller always needs to be able to get that map, but only the controller has access to that map. The nodes have no idea.
Yeah, but it has to be in some kind of database, like Memcache, or I don't know, something like that.
We put it in a Kubernetes CR. That's where we store it. So that particular feature just layers on top of Kubernetes CRs. But yeah, we keep track of that stuff. So I guess we can consider it as something that could be improved on the CSI spec side, but given that there is a solution that already works, I find that one less critical.
So is that the list volume only used for checking volume still attached or not?
Yeah. So when the external attacher sidecar starts up, it calls list volumes to try to see what is already published, and then it reconciles that against the volume attachments that it knows exists on the Kubernetes side. And if there's any situation where you have a volume attachment, but the CSI driver says it's not published, it will recall controller published volume at that time to try to fix it. That's a very cool feature on the external attacher sidecar. I'm a big fan of whoever added that. I don't know who added that, but I like it.
But actually, I feel that hides some issues there. But we can talk details later. This is kind of less important since it has a workaround. I agree. Ben, do you have like more concrete design for the third approach, and what problem can be solved and what cannot be solved, and so we can think how to solve like
Yeah. So
rest.
The third approach is most squarely aimed at the stuff that is in the CSI driver object. So things like FS group policy. I guess the SC Linux label policy isn't there yet, but short of adding a new CSI feature, like the way we would address it on the Kubernetes side is by extending the CSI driver object with a new field, right? Because it's just quicker and easier to just do that on the Kubernetes side and not touch the CSI spec.
It's coming in 125. It's just Jan is working on it.
There's a new field in CSI driver.
Yeah.
And no CSI spec change. Okay, so yes, so those two features are the ones that could be addressed by basically making the CSI driver object have multiple instances, or by changing it to have maps instead of, global fields. But I'm pretty sure that it would not help with the per node limits. So
is the per node limit is the only like thing left that cannot be solved?
That was the only issue raised last week that we have no other solution to.
No, and the capacity tracking also cannot be solved.
Well,
No.
Well, what is wrong with the status quo on capacity tracking?
So it's basically same as node limits. Each node reports how much capacity is available. I don't remember if it reports available or consumed, but it reports a value. Now, if the CSI driver is, for example, vSphere CSI driver is providing both block storage and file storage, they literally come from different data stores, and they could have different this thing, like they can report different capacities. So
but capacity is a controller RPC, not a node RPC.
it's on the controller side. Sorry, it's on the node side, I think.
No, I'm looking at the spec right now and I see it's
I believe it's controller side because the external provisioner is using it, right? So
yeah, it's a controller only RPC, but you can pass it in a topology constraint.
I think it's because you're using that in a distributed mode. So that's why you deploy it on the node. Your storage is tied to your node, but that's actually a controller side thing.
But even in that mode, you don't run the controller plugin on every node. You still just run one instance of it, I thought.
Oh, no. In that mode, you do run on every node. Yeah.
Yeah, it's distributed. Every node is like your storage, basically.
Okay, so okay, I'm less familiar with that way of doing things, but just so I understand, so if you're in that mode where you're basically running the controller plugin on each node, and the particular plugin you're using has different subtypes of volumes that it can support, you're saying that the existing inputs to that RPC, which are the topology, the parameters, and the volume capabilities, don't give you enough of a filter to basically say how much of this type of storage do you have versus how much of that type of storage do you have?
Yeah. Yeah.
What would be ideal then? Because this is the question that you're asking before any volumes exist, right? Like it could be for the very first volume. You're saying how much capacity do you have available, and
yeah, how much capacity you have available? What is the maximum size you can provision? So it's like you're asking this, and the provisioner uses this information to give you a volume. Now, if you, depending on which type you're asking, the answers of the available capacity may change, right?
Yeah, but that's to be expected, right? Like the driver is going to just, like, let's say you have NFS and ISCA as usually two options. The provisioner, or the create volume request handler, is going to decide whether to give you ISCA as your NFS based on exactly the same inputs. It's going to be the topology, the storage class parameters, and the capabilities that you ask for. And whatever matches those things, it will choose that type of volume and give it to you. And so it seems like, in principle, if you're passing the same inputs into get capacity, it should be able to perform the same computations that create volume would have performed to figure out what kind of thing to give you, and then figure out what the biggest one of those that it can make is, or how much total space there is for making that kind of thing. Because there would be no volume subtype at that point because you haven't created the volume yet. You've just, all you have is a storage class on the Kubernetes side, and you're saying, can I create a 100 gig volume or a 100 terabyte volume? And the driver has to say, well, yeah or no.
So at least for the volume limit, I feel it's still possible by changing the spec to solve it, right?
Well, but you have to plumb the spec change not only through the CSI spec, but through Kubernetes too, because that communication between kubelet and the scheduler is also not comprehensive enough to do the right thing.
Yes, we have to change both sides, but it's doable.
Yeah, it's doable. It's just a lot of work.
And it's just how would we even do it? Like in the scheduler, like you have the CSI, the scheduler. First of all, scheduler folks don't like to have a lot of dynamic information. They like information that they can cache so that they can respond fast. But in this case, it sounds like scheduler has to look into different.
This would all be cacheable information. It would just be that you would, instead of having one value, which is I have a limit of X volumes per node, it would be for subtype A, I have a limit of Y, and for subtype B, I have a limit of Z. But those numbers wouldn't be changing. And the scheduler knows what subtype the volume that it's considering scheduling is, because we would have to store that too.
Where would we store it in?
It would have to get onto the PV somehow. Because in addition to the CSI driver name, you would need the CSI driver subtype name to come along with it.
And the initial design, do we have that in mind? Like for each driver, it only supports kind of one volume type, and each PV, right?
Well, yeah, but by default, I think you would say subtype is empty, right? So for the majority of drivers that don't have subtypes, they would just use the empty string and they would be backwards compatible with themselves. And then for any of these weird drivers that do have different subtypes, they would still have to support an empty subtype for backwards compatibility and basically guess the right behavior. But then for ones that had non-empty subtypes, you could give them the right answer.
And also the PV/PVC need to have that type information.
The PV would, not the PVC.
Okay.
We would need to stick it in the PV alongside the CSI driver name.
Okay.
Some CSI subtype field.
Okay. So I feel if we can like iterate, right? But if it works to do it, I think it might be a direction we really want to discuss.
Okay, so you're saying let's flesh out option number 3, or maybe a combination of options 2 and 3.
Right, correct.
So that we can also address the per node limits issue similarly. Okay, I'm comfortable with that as a path forward. It is, and oh gosh, we're almost out of time. So yeah, let's see if we can reach agreement on that as a tentative direction, and then maybe next meeting we can get into detail on what exactly that looks like, so we can pick at it. Is there anyone who thinks that's a terrible idea? I know that Michelle was the one that was arguing against it, and we seem to have lost her.
The option 3, right?
We're suggesting a combination of options 3 and 2 going forward.
I think she's not like completely rejecting. She was just saying we may not solve all the problems. So we probably should just write out, if you write out some details, then we can go through it.
Okay.
Yes. See what are the problems that we think are not solved by this 2+3.
Okay. All right. Yeah, and it's helpful to think about all of the actual touch points on the Kubernetes API that would be needed to introduce the concept of a subtype, because it would have to be a new field that would have to go through alpha, beta, GA. And we probably have one big feature gate that would cover all of this on the Kubernetes side.
If you can get this solved, then I think it's worth it, right?
Yeah.
Right. I think we need to start like we cannot not changing anything, right? And it
Yeah.
needs to be solved based on all the issues.
Okay. Well, I'm glad that there's energy behind this, because yes, something this big and daunting can easily just make people run away and go work on other stuff. But I'm glad that people are interested in getting to the bottom of this one, because I am. So okay. So thank you all. We're gonna have to end the meeting. I'm gonna again try to capture the notes, except I can't do it in the following hour because I've got other meetings today. But at some point I'll dump my memory back into the notes, and we'll have a starting point for the discussion next week. All right.
Yeah.
Thank you.
Thank you, Ben.
You.
Yeah.
Bye.
Bye.